My name is Danko Emmanuel Kenjo, and I welcome you to Kentech 96 TV. For today's lesson, we are going to solve some past mid-semester examination questions. And for question one, and this is a question that came in the year 2018. And from the network below, we are supposed to calculate the current in the network using superposition theorem. So we are supposed to calculate R1, the current which is flowing through resistor R1, R2, and R3 using superposition theorem. So for superposition theorem, it states that anytime you want to use superposition theorem and you have two sources or more, for this particular question, we only have two sources, one and two. So whenever we want to use superposition theorem, we are supposed to deactivate either one of them, then solve the question with respect to only one. So here we are going to start solving this question by deactivating the 20 volts. And anytime you want to deactivate a voltage source, you represent it with a short circuit. So using superposition theory, we are going to deactivate one of the source. So here, let's start by deactivating the 20 volt source. And since it's a voltage source, we will replace it with a short circuit. Then we will calculate the current flowing through resistor R1, R2, and R3 when the source voltage of 10 volts is acting. We are going to have resistor 2 ohm connected in parallel with the 3 ohm, and the results of this will be in series with the 1 ohm. In other words, R2 or R3 will be connected in parallel with R2, and the results will be in series with R1. So here we are going to have 2.2. So that is the total resistance of the circuit. But from Ohm's law, V is equal to IR. Therefore, our I will be equal to V over R. So here the voltage source in the question is 10 volts over the resistance, which is 2.2. So remember to add the unit, 10 volts, 2.2 ohm. So if I divide 10 by 2.2, I'm going to arrive at 4.54 amps. So meaning the current which is flowing through the circuit when the 10 ohm resistor is 4.54 amps. So this 10 volt source will drive a current of 4.54 amps. So let's say when this 4.54 amps gets to this junction, it will split. We are going to have, let's say, we are going to have I1, I2. So for us to calculate the current flowing through resistor R2 and R3 when the 10 volt source is active, we can use what we call the current divider rule. So to calculate the current flowing through resistor R2, we are going to have I2 equal to R3 over R3 plus R2 times the source current, which is I. So we are going to have R3 is 2 over 2 plus 3 times the source current, which is 4.54 amps. So here we are going to have a current of 1.818 amps, which is the current flowing through resistor R2. Now to calculate the current flowing through resistor R3, from Kirchhoff's current law, we know that I is equal to I1 plus I2. So if I've been able to calculate for my I2, it means I can calculate for I1. So I1 will be equal to I minus I2. So I'm going to have 4.54 minus 1.818, and this is going to give 2.724 amps. So after this analysis, we realize that when the 10-volt source is active, we have I to be equal to 4.54, I2 to be equal to 1.81 amps, then I1 also to be equal to 2.724 amps. So now let's consider the other source and calculate the current flowing through the other resistors. So let's analyze the circuit again. When the 20-volt source is active, then we will have to deactivate the 10-volt. Then we calculate the current flowing through resistor R1, R2, and R3. When the 20-volt is active, we are going to have our voltage to be equal to 20 volts. But to calculate for our RT, which is the equivalent or total resistance, we are going to have R1 in parallel with R2, and the total of this in series with R3. Now, the value of R1 here is 1. So 1 in parallel with 3. Then the sum of this will be in series with R3, and the value is 2. So when you simplify this, we are going to have 2.75 ohm. Then from Ohm's law, our V is equal to IR. So if I want to calculate the current produced by the 20-volt source, I'm going to have I, which is equal to V over my RT. Now the voltage here is 20 volts, and the total resistance is 2.75. And if I should simplify this, this is going to produce an answer of 7.27 amps. So what it means is that the 20-volt source will drive a current of 7.27 amps. So this current will flow through resistor R3, and when it gets to a junction, it's going to split into, let's say, I2, I1 here. So what it means is that to calculate the value of the current flowing through resistor R1, when the source is 20 volts, we can still use the current divider rule. So if I know for 20-volt source, the current is 2.72 amps. So if I want to calculate the current flowing through resistor R1 when the source is 20 volt, I'm going to have I1, which is the current flowing through resistor R1, to be equal to R2 over R1 plus R2 times I. Then I1 is going to give me 3 over 3 plus 1 times the source current, which is 7.27 amps. So I1 will be equal to 5.45 amps. Now, if current entering the junction should be equal to current leaving the junction, and I have the source current to be 7.27 amps and I1 to be equal to 5.45 amps, then definitely my I2 will be equal to the 5.45 minus, so I'm going to subtract my I1 from the 7.27 amps, and it's going to give me 1.818 amps. So when the 20-volt source is acting, I'm going to have current which is flowing through resistor R3 at 7.27, current which is flowing through resistor R1 to be equal to 5.45 amps, and the current flowing through resistor R2 as 1.818 amps. Okay, so after taking into account the two voltage sources, for the 10-volt source, we had a current of 4.54 flowing through resistor R1, a current of 2.72 flowing through resistor R3, and a current of 1.818 flowing through resistor R2. Then for the 20-volt source, we had a current of 7.25 flowing through resistor R3, a current of 5.45 flowing through resistor R1, and 1.818 flowing through resistor R2. So to calculate the current which is now flowing through resistor R1, so for R1, the current flowing through R1, let's say, should be equal to I1. So I1 will be equal to the sum of these two currents, but let's be mindful of the direction. So here we are going to have 4.54 minus 5.45, and the current which is flowing through resistor R1 is going to give us minus 0.91. Then the current which is flowing through resistor R2, let's say that one, the current is so for R2, we are going to have, let's say, I2, and I2 will be equal to the current flowing through resistor R2, and that is equal to 1.818 plus 1.818, and this is going to give us 3.64 amps. Then lastly, the current flowing through resistor R3. So for R3, let's call it I3. So I3 will be equal to, let's also consider the direction again, 7.25 minus 2.72, and I3 is going to give a current of 4.55 amps. So after using superposition theorem to simplify this circuit, we had the current flowing through resistor R1 as negative 0.91 amp. Then for the current flowing through resistor R2, we had 3.64 amps. And I3, which is the current flowing through resistor R3, we had 4.55 amps. So let's move on to question number 2. Okay, so for question 2, we are supposed to find the current flowing through the 1.5 ohm resistor using Thevenin's theorem. And for Thevenin's theorem, what you are supposed to do first is you are supposed to first identify your load resistor and mark the terminal. And the load resistor becomes the particular resistor in which you want to calculate the current flowing through. So here, the 1.5 ohm becomes our load resistor. So we will remove the load resistor and mark the terminals as A and B. Then we calculate the voltage across the open circuited part, which is normally called Thevenin's voltage, VTH. So for us to calculate our VTH, we have two sources. One is 8 volt and the other one is 12 volt. So each of them will drive a current. So let's say this 8 volt will drive a current of I. Now this I will flow through this resistor, which is 1.0 ohm, and also flow through the resistor 3.0 ohm. Remember, when it gets to this junction, it's supposed to split, but because this side has been open circuited, the current will just flow through this part. And when this also drives a current, let's say I1, the I1 will also flow through this resistor and this without flowing through this side because it has been open circuited. So to calculate for our VTH, we need to know the current flowing through this 3.0 ohm resistor and 1.6 ohm resistor. So here, I can take this as my loop 1, then this as my loop 2. So for loop 1, I'm going to have 8 equal to I plus 3I. and this is 8 equal to 4I. Therefore, my I is equal to 2 amps. Then for loop 2, I'm going to have 12 equal to 2.4I1 plus 1.6I1. And this is 12 equal to 2.4 plus, we give 4I1. Therefore, my I1 here will be equal to 3. So now, once I've been able to calculate I and I1, I will be able to calculate VTH, because VTH here, let's say VTH, to calculate for VTH, we can use this loop, the middle one, to calculate for VTH. Because now we've been able to calculate for our I and I1. So here the current flowing through this side is 2 amps, and the current flowing through this part is 3 amps. So to calculate VTH, taking this loop, I'm going to have my VTH equal to 3 multiplying 2 plus 3 multiplying 1.6. So here 3 times 2 is going to give 6. 3 times 1.6 is going to give 4.8. So the final answer will be equal to 10.8. Therefore, my VTH is equal to 10.8 volts. Then I'm left to calculate for my RTH, which is Thevenin's equivalent resistance. Thevenin's equivalent resistance, which is RTH, which is the total resistance seen between the terminals. So if I look through these terminals, I'll be able to identify this resistor and this connected in parallel. This together with this also connected in parallel, and their resultant will be in series. So I can have my 1.0 ohm in parallel with 3.0 plus my 1.6 in parallel with 2.4. So if I want to simplify this, this is going to give 3/4 plus 0.96, and the final answer will be equal to 1.71 ohm. Therefore, Thevenin's equivalent resistance will be equal to 1.71 ohm. Be able to calculate our VTH and RTH. Then lastly, we are supposed to produce Thevenin equivalent circuit such that the Thevenin equivalent resistance will be in series with the load resistor. So we are going to have a DC source voltage, which is VTH, and the value is 10.8 volts. Then this is going to be our RTH, which is 1.71 ohm. Then the value of our load resistor, which is 1.5 ohm. Then we calculate the current flowing through them. Now, since the load resistor is in series with the Thevenin equivalent resistance, we can add them. So to calculate the current flowing through resistor, 1.5 ohm, which is the load resistor, IRL, which is current flowing through the load resistor, will be equal to VTH over RTH plus RL, and this will be equal to 10.8 all over the RTH is 1.71 plus the load resistor 1.5, which is going to give an answer of 3.36 amps. So the current which is flowing through the 1.5 ohm, which is the load resistor, is 3.36 amps. So for question number 3, we are supposed to find the current flowing through resistor 8 ohm in the circuit below. And this is a SEM past question 2021. So we are supposed to calculate the current which is flowing through this 8 ohm resistor. So now we have two sources, 45 volt source and 20 volt source. So what we can do is that we need to introduce loops. So let's say this 45 volt will drive a current called, let's say, I. This 20 volt source will also drive a current I1. So when I and I1 meets at this junction, all the current will now flow through the resistor 8 ohm. So we are going to have I plus I1 here. So now we can have two loops. One here, loop 1. Then this time around, I'll go this direction, loop 2. So I'm going to have these equations for loop 1. I'm going to have 45 equal to 4I plus 8 into bracket I plus I1. So this is going to be 45 equal to 4I plus 8I plus 8I1. 45 equal to 12I plus 8I1, and this is equation 1. Then for loop 2, I'm going to have 20 equal to 2I1 plus 8I plus 8I1. I'm going to have 20 equal to, when I simplify them, I'm going to have 10I1 plus 8I. Rearranging, I'm going to have 20 equal to 8I plus 10I1, and this becomes equation 2. So then you can solve equation 1 and 2 simultaneously on your calculator. You just have to go to mode 5 equations, then you select 1. So you can solve equation 1 and 2 simultaneously. And when you do that, you are going to have I equal to 5.17 amps. Then I1 will be equal to negative 2.14 amps. But remember, to calculate the current flowing through the 8 ohm resistor, we can have it as I plus I1. So here I'm going to have 5.17 amps minus 2.14 amps. And this is going to produce an answer of 3.03. So it means that the current which is flowing through the resistor 8 ohm is 3.03 amps. Or we can also distribute the current such that when the 45 volt source drives a current I, when the current gets to this junction, it's going to split. We are going to have I1. So if I take I1 from I, that will be the current flowing through the 8 ohm resistor. So I minus I1. Then I'll introduce the looping. So loop 1, loop 2. So for loop 1, I'm going to have 45 equal to 4I plus 8 into bracket I minus I1. So 45, simplify, I'm going to have 45 equal to 12I minus 8I1, which is equation 1. Then for loop 2, I'm going to have 20 equal to, now I'm going this direction and this is also going this direction, so I'm going to have negative. So here you need to consider the direction. So I'm going anti-clockwise and this is coming clockwise, so I'm going to have negative 2I1 plus 8 into bracket I minus I1. So here will be equal to 20 equal to negative 2I plus 8I minus 8I1. So here I'm going to have 20 equal to 8I minus 10I1. And this is equation 2. So I can also solve equation 1 and 2 simultaneously. We are going to have I, which is equal to 5.178. Then I1 will be equal to 2.142. But remember, to calculate the current flowing through the 8 ohm resistor, we had the current to be equal to I minus I1. So here we are going to have 5.178 minus 2.142. And the final answer will be equal to 3.08 amps. So what it means is that the current flowing through the 8 ohm resistor is 3.03 amps. Thank you for watching Ken Tech 96 TV.